let us say that we have a electric field, uniform electric field in this direction, and the magnitude of the electric field is 50 Newton per Coulomb. It can also, the units can also be written in terms of volt per meter, so don't get confused in this, okay, in books, because E is equal to minus dV by dr, right? So if I have 2 points A and B, AB is parallel to the electric field line, and the length of AB is given as 100 meters, and the potential at B is equal to minus 20 volts. Find the potential at point A. I will solve that, okay? Listen very carefully what we are doing. So we are using electric field is equal to minus dV by dr, right?
Yes.
Or we can simply say the magnitude of potential difference is equal to simply electric field into dr, because we already know high potential, low potential. You said it is better to do it intuitively rather than substituting in the formula and stuff. We will get it either way.
Yes, sir.
Okay, we will get it either way, but like you said, you're comfortable this way. I'm explaining it this way. So first we have to find what is the magnitude of product of electric field into dr, or which is nothing but magnitude of delta V. So electric field is 50 and dr is 100. So this is 5000. You got this much, right?
Yes, sir.
Now what should we do in the next step? This point is A, this point is B. Delta V, we can say this is high.
I understood, sir.
VA is greater than VB.
It is VA minus VB equal to
VA minus VB is equal to 5000. Therefore, VA is equal to
yes.
how much?
It will be
4,980, right? And I like your confidence while giving the answer. There is an uniform electric field in this direction. The magnitude of electric field is 10 volt per meter. It is at an angle of 37 degree to the horizontal. I have 2 points P and Q. The coordinates of point P and Q are P, we can take it as 50, 50 in meters. Okay.
Yes, sir.
The coordinate of Q, we can take it as 100, 50. This is also in meters. Okay.
Yes, sir.
If potential at P is equal to 20 volts, find the potential at Q. I'll repeat this question. Electric field is 10 volt per meter at an angle 37 degree with the horizontal. There are 2 points P and Q. The coordinate of point P is 50, 50. Coordinate of point Q is 100, 50. If potential at point P is 20 volts, find the potential at point Q.
Will I count them? Sorry, but the next part.
Let me explain. I'll explain both of them and then give you questions. Okay. See, the previous question, 15th question, and 16th question are not much different
Yes.
because point P and Q, I have given the coordinates, but actually it's still horizontal. Line PQ is horizontal
Yes.
because the y coordinate of both the points is same.
Yes.
Therefore, all I am interested in is in the electric field along x-axis.
Yes.
I am not interested in the electric field in y-axis
Yes.
because PQ is along x-axis, parallel to x-axis. The component of electric field parallel to x-axis is simply E cos 37 degree. So, first, anyways, I know the potential difference is equal to electric field into distance. But here, even though it is given in terms of coordinates, we know that the line PQ is parallel to x-axis.
Yes.
That means when I am doing delta V between P and Q, it is nothing but delta Vx.
Yes.
And in place of electric field, I will have Ex, which is E cos 37. Okay. And in place of dr, I will have dx. And that dx is nothing but the length of line PQ, which is 100 minus 50, which is 50 meters.
Yes.
Okay.
Yes.
Now, substituting everything over here, E cos 37 is nothing but electric field is 10, cos 37 is 4 by 5, so electric field is 8.
Yes.
So 8 into 50 is 400,
Yes.
and the component of electric field Ex is from left to right.
Yes.
Therefore, I can write it as Vp minus Vq is equal to 400.
Yes.
Vp is given as 20 volts. I can get Vq.
Yes.
Okay. Let me come to this question. Okay.
Yes.
The coordinates which are given are 2, 3 and 6, 6. That
Yes.
means that I have to look at uh, both x and y independently.
Yes.
So if I will draw this as a triangle, A, B and C. Okay. Coordinate of A is 2, 3. Coordinate of B is 6, 6. If I go along x-axis, then my coordinate of C will be 6, 3 because
Yes.
x has to be the same, and from here y has to be the same.
Yes.
Now if I will look at the lengths of these, I have this length as 4 meters and this length as 3 meters.
Yes.
and this angle is 37 degree.
Yes, sir.
Why I paused initially while explaining this is I mentioned 37 degree, but even if I don't mention 37 degree, you know, I'll have to mention the direction of electric field, but this direction of 37 degree is not because of that angle is 37 degree.
Yes, sir.
I will show it in the next question what I mean. Okay, so I'll repeat the question again. Electric field magnitude is 10 volts per meter at an angle 37 degree with the horizontal. 2 points are given, 2, 3 and 6, 6. If the potential at B is minus 50 volt, find the potential at A. The question is find the potential at A. Okay?
Yes, sir.
Because there is an electric field in the XY plane, that means it is not just along x-axis or not just along y-axis, right?
Yes, sir.
There will be an electric field component along x-axis, electric field component along y-axis. This is point number 1.
Yes, sir.
Which was there in that question also. Next, points 2, 3 and 6, 6 are given. That means there is variation of x value and also variation of y value, which is different from that question. There we had only variation in x, no variation in y-axis, along y-axis.
Yes, sir.
Here we have variation in both x-axis and y-axis.
Yes, sir.
Next, whenever I have a situation of this type, I should always go in terms of components.
Yes, sir.
Easiest way to solve it.
Yes, sir.
Coordinates 2, 3, 6, 6 are given. So I am going to create a right angle triangle. It's our preference. You can go first along y-axis, then along x-axis. I usually go along x-axis, then along y-axis.
Yes, sir.
So if this coordinate is 2, 3, the next coordinate will be 6, 3. First change x, then change y. So this coordinate is 6, 3. The last coordinate is going to be 6, 6.
2 points. Not 6,
Yeah.
Won't it be 2, 6?
While going along y-axis, the x coordinate should be same.
Yes, sir.
So, good morning. While going along x-axis, y coordinate should be same. So while starting from 2, 3, I will go to 6, 3. Only x will change. While going from 6, 3 to the top, it will become 6, 6, which is my final coordinate. I have to reach from A to B, draw a horizontal line, draw a vertical line, and generate a right angle triangle.
Yes, sir.
Now, it is given in the question that the electric field makes an angle 37 degree with the horizontal, but in the beginning I was paused because it happened so that the coordinates that I gave, this triangle is also making, hypotenuse is making 37 degree with the horizontal. It's just by chance. I will solve a different question without any of these chances. Okay.
Yes.
So in this case, simply we have electric field E parallel to the line AB.
Yes, sir.
We can say unfortunately also. I'll tell you why. So let us first do the longer and intended method of why I gave this question. then we will solve it in the easier and non-intended way of solving. Okay,
Yes, sir.
take a look. So here what I am saying is we should do delta Vx individually and delta Vy individually.
Yes, sir.
Is this clear?
Yes, sir.
So first I will go from A to C, then I will go from C to B, eventually getting the potential difference across A and B. Why am I doing horizontal independently and vertical independently? It's easy for me to get the components of electric field along x-axis, y-axis and treat x-axis and y-axis independently, because the concept says that the effect of any vector in its perpendicular direction is zero. So the effect of electric field vector along x-axis has no effect along the y-axis. So I am going to treat electric field along x-axis and y-axis independently. Therefore, I am going to get delta Vx and delta Vy also independently. When I do delta Vx, it will be between points A and C. When I do delta Vy independently, it will be between points C and B.
Yes, sir.
Now again, intuitively, keeping the direction in view, we are going to do VA minus VC or VC minus VA, higher potential to lower potential story.
Yes,
It is
sir.
once you practice more and more problems from all the sources that you have, eventually you will see both are using delta V minus delta V is equal to E delta X. That also is not of a big deal, and this is also intuitively also is not a big deal. Both are more or less the same. You will eventually realize it, but right now we will keep it in an intuitive way. All we need to remember is that when I am doing my x component, my points should be A and C. When I am doing my y component, my points should be C and B. Clear?
Yes, sir.
Okay, let's move ahead. So first let us do this story. Okay.
Yes.
You only tell me. So this should be electric field X and electric field Y, EX and EY, right? First let us find out what is EX and EY. Yeah. What is the component of electric field along x-axis?
It is cos.
10 cos 37.
Yes, sir.
How much is it?
Or sorry. 4/5 into 10.
Mathematics. 8. So what is the component along y-axis?
36.
Whenever we have 10 and 37 degree, 53 degree, we will have it at 6 and 8. We only have to check where is it 37 and then think of where the numbers are 8 and 6, right? Okay, nice. So let us substitute it over here. Delta Vx is equal to, what is Ex?
8.
Into what is Dx?
34.
So we can say this is 32 volts.
Yes, sir.
In between, when we are doing along x-axis, we are working in between points A and C, right?
Yes, sir.
Tell me, is VA greater than VC or VC greater than VA?
Greater than.
Because the electric field is from left to right. So VA is greater than VC. So delta V, intuitively, what should I write? Mod delta Vx.
Positive.
No. Too much mathematics solving. VA minus VC. I wrote that over there. So VA minus VC is equal to 32 volts. and we don't know what VA is. We have to find what VA is. Only VB is given. So let us take this as first equation. Okay.
Yes, sir.
Next, let us do B and C now. Okay. So mod of delta Vy is equal to Ey into dy, right?
Yes, sir.
So mod delta Vy, what should I substitute?
10 into 3, 6 into 3, sir. 18.
6 into 3, which is 18 volts. Now, is Vc greater than Vb or Vb greater than Vc?
VB should be greater than.
Obviously, because that fellow is at a very high height. Whoever stays in 10th floor is rich. Whoever stays in first floor, ground floor is poor. A genius fellow. You should look at the direction of electric field to figure out where is higher potential, where is lower potential.
C is greater than.
Okay, so give me one final answer.
VC minus VB. It's positive.
Okay, too fast, too fast. So VC is greater than VB, sure, right?
Yes, sir.
Because the electric field is from C to B.
Yes, sir.
So here I'll write it as VC minus VB is equal to 18. Here we know what VB is, minus 50 volt, correct?
Yes, sir.
So by substituting VB is minus 50 volt, tell me what will I get VC as?
When we take magnitude of
Magnitude of?
VB.
No, that's why magnitude is only for delta V. Once we come to individual values of VC and VB, we will substitute whatever is given. What is VB? VB is minus 50.
Okay.
So when you substitute minus 50, what will you get VC as?
You take minus
How much is it?
32.
Minus 32.
Yes, sir.
VC is equal.
It should be positive.
VC is equal to 18 plus VB. 18 VB is minus 50. So it is minus 32 volts.
Yes, sir.
Okay. Using this, VC is equal to minus 32 volts in equation 1.
Yes, sir.
What is VA?
Third 60.
It is
0.
0. So this is also sheer coincidence. When I gave the question, I did not intend them to be 37 degree, and I did not intend for this fellow to be 0 volts. Okay, it just came out like that. Is that clear? I'll solve this one. Okay, then I'll give you another one.
Yes, sir.
So again, there is uniform electric field. Magnitude of electric field, we take it as 10 volts per meter. It is at an angle of 37 degree with the horizontal. Let us choose 2 points, A and B. So clearly I am showing that the line AB is not parallel to electric field. So we can take the coordinate of A as anything, let's say 50, 60, and the coordinate of B as 100, 70. Okay,
Yes, sir.
all in meters. Now it is given that the potential at B is equal to 0 Find the potential at A. Okay.
Yes.
Now, first thing that I want to do is use the coordinates and make a right angle triangle. Okay, so this point is A, has a coordinate of 50, 60. Okay.
Yes.
Then go along x-axis, name it as a point C. Yeah, 100, 60. And now go along y-axis and we will reach to our destination, that is 100, 70.
Yes.
So what is dx or delta x over here? 50 meters.
Yes.
Because we are going from 50 to 100. What is dy? We are going from 60 to 70. 10 meters. Okay. Is our dy. Is this clear?
Yes.
Next, convert our electric field into horizontal and vertical components. So what will be the horizontal component? What will be the vertical component? We have 10, so it is going to be 6 and 8.
Yes.
8 I cap plus 6 j cap.
Yes.
Because angle is 37 degree. So along x-axis Ex is equal to 8 volt per meter and along y-axis Ey is equal to 6 volt per meter. Clear?
Yes, sir.
Magnitude of delta Vx is equal to Ex into dx. Correct?
Yes, sir.
So what is Ex into dx? 8 into 50, which is 400. What is my delta Vx? Va minus Vc or Vc minus Va?
Minus V, sir.
Va minus Vc is equal to 400. He has not given us Va or Vc, so I will take this fellow as my first equation. Okay.
Yes, sir.
Next, magnitude of delta Vy is equal to Ey into dy. What is Ey into dy?
6 into 10, 60.
6 into 10, which is 60. Is Vc greater than Vd or V?
VC is greater than VP.
Yeah, this coordinate. So here we'll write Vc minus Vb is equal to 60. Right?
6.
It is given that Vb is 0.
VC is 60.
Vc is 60. Using this value in the first equation, Va is equal to 460 volts. Clear?
Yes, sir.
Take this down. I will give you another one. Till that time, you take this down. Electric field is 100 volt per meter at an angle 45 degree with x-axis. The coordinates, I have not shown it like I was showing it over there. I just gave the coordinates as minus 5, 6 and 10, 10. It is up to you how you make your triangle. Right? Obviously. Next. It is given that the potential at point B is 0. Find the potential at point A. So first to make the triangle, then only your VB is equal to Z. All these things will come into it. So I'm getting VA minus VB is equal to 950 root 2 and VB is 0. So therefore it is 950 root 2. Correct. Good. Yeah.
I mean, you calculated everything.
Yeah. If this is slow calculation actually. You will also solve even more faster once you practice questions, but within 1 week. Okay.
Yes.
See, this how I imagine in my head is like this because most of the questions that I solve, even in mathematics, also, even if they are analytical solving, most of the questions that I solve is mainly imaginary. So, how I look at these things as I look at a staircase. How do you climb a staircase?
Perfect.
What is the motion of body while you're climbing a staircase?
Oscillatory.
You raise your leg up.
Yeah, it's
Oh,
like to and fro.
I'm saying you take your coordinates
Okay.
x and y individually.
Yes, sir.
It's not a slope.
Yes, sir.
So you're not actually going randomly. You're raising your feet, putting your feet up,
Yes,
then
sir.
raising your feet, putting your feet up. In the sense that y-axis, x-axis, y-axis, x-axis, y-axis, x-axis. That's how your staircase is.
Yes, sir.
So irrespective of what you give, I will get the components along x-axis, y-axis and start multiplying my delta x, delta y to the respective ones. Of course, the best thing about this is potential is a scalar.
Yes, sir.
But risky part is that I have to know which is a higher potential, which is a lower potential.
Yes, sir.
That is important, right? Okay. Electric field here is 60 volts per meter, making an angle 53 degree with negative x-axis. Be careful. The coordinate A and B are given as minus 10, 10 and 3, 4. Potential at A is given as minus 50 volts. Find the potential at B. Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.